I want to teach you projectile in physics in a way you will never forget. You are going to understand projectile as if you are eating Eba. But in case you don't still understand after I finish this class, just know that what physics is not for you. Go and find another thing to do. And if your father insists that you must do physics, don't do physics. So simply use that school fees money, go buy Jetta. Just tell your daddy, I am not Charlie Poppy Jr. Your father, I will slap you. Daddy, wait. They call me Charlie Poppy Jr. That is your calling. After all, who school help? You know how you used to encourage yourself. Who school help? Forget, you get JK, just come out. Now, let's get started. Projectile. Before we start, you need to understand the application of projectile so that you will appreciate what you are going to do. I want to ask you, do you know that if Russia or America were to, from New York, any part in USA, to strike any location in the world, they can do it from there. They can be here in America and throw a missile that will land in Abuja or in Afghanistan. If you release an object, either a stone or a missile, you agree with me, as the object is flying, the force of gravity will be pulling it down. Because of the force of gravity, it will be coming down until it comes back to the ground. That is this you are seeing, the movement of an object you shoot. This is very versatile and very useful in different fields of life. I have to say that without wasting our time, the first thing we are going to look at now is the velocity, because when something is moving, it has velocity. That velocity, we are going to look at it that this is the way we shoot you. We shoot you like this. This is the way we shoot you. That is U. We can also call it V0. That is initial velocity. Okay? This initial velocity, we are going to stick by this, is this line. But because of nature, a force is dragging it down. That is gravitational force. So instead for the stone to go like this, it went against to this point, that is the peak, the highest height. Then it comes back. So here, we can call it H. That is the maximum height. Now, you can also calculate the starting point to where it landed. This is called what? Normally, distance. But because we are discussing projectile, we don't call it distance, we call it range. Okay? We call it range. It's the same way if you have money in your hand, it depends on what you want to do with the money or where you got the money. We can call it loan, we can call it dowry. If you are meant to pay a bride price, we can call that same money savings. You can call same money another name. The same thing. Distance in terms of projectile, when we are calculating the distance covered by the object, when it is released, is called range. This is also like distance, height. But we call this one what? The maximum height. Okay? There's a reason why I'm mentioning this, because we are going to use this term. Now, we cannot just use this velocity. When you want to use this velocity, you can't just put it like that. You have to get the component of this velocity in this direction and the component of the velocity in this direction. This is like the resultant. But we need to get the exact equivalence of this in vertical direction and that of what? Horizontal. So we call this one the horizontal velocity. After we get the component of this in this direction, we are going to call it horizontal velocity, while the component of this in this direction, we are going to call it vertical velocity. It's like you have money that is meant for two people, and you combine the money together. And the time you want to separate the money, say this belongs to James, this belongs to Peter. So this is the resultant velocity, the equivalence in vertical direction and this in horizontal direction. So we are going to call this UY, the component of this in this direction, and the component of this in this direction, we are going to call it UX. Okay? The angle between this line and this horizontal direction, we are going to call it, let me remove this from here first. We are going to call it theta. Why this, as I said before, I'm going to put UX. I want to show you how each of these came about. This is the y-axis, this is the x-axis. This you are seeing here, sometimes you can call it capital letter H. It's allowed. Okay? Now, what are we going to use this to study? Look at what we are going to calculate. We are going to calculate horizontal velocity, vertical velocity, maximum height, time to reach maximum height, total time of flight, and range. What do I mean by calculate? That means we want to prove each of these, the formula for each of these. We want to see them, want to see how they all came about. So the first one is the horizontal velocity. Let's see. For this horizontal velocity, you will agree with me if I take this now, I take this, I take theta. You get it? This is the UX, theta, and this is the U. To get this US, you agree with me, this is what? Adjacent. This is hypotenuse. When adjacent and hypotenuse comes together, remember Projectile in trigonometry, you agree with me that is cosine. It means cos theta is equals to adjacent over hypotenuse U. So this we are looking for is equals to U cos theta. This is the component of U in this direction. Okay? We call this one what? The horizontal velocity. Why the vertical velocity is this one? That is, if I take this one, I take this, I take this, this is theta, I can transfer this to this side. It means this UY can also be UY here. I'm transferring this to this side. Okay? Why this is U? It therefore means that I can simply get this, get this, get this. This is UY, theta, and U. We are looking for this. This is opposite to this angle. This is hypotenuse. Therefore, it means sine theta, because when opposite and hypotenuse comes together in Projectile, show opposite hypotenuse. Adjacent hypotenuse, which we used earlier. We use opposite and hypotenuse to talk about sine. That's why we are bringing in sine theta, which is equals to opposite over hypotenuse. Therefore, this is equals to U sine theta. As you can see, this is what? The vertical velocity. So, whenever you want to calculate vertical velocity, is the velocity given sine theta, while horizontal velocity is the velocity given cos theta. That's multiplied by cos theta, multiplied by sine theta. Put that at the back of your mind. The next one is maximum height. How do we calculate this maximum height? Maximum height. Okay. What I'm going to do, I will open a new slide. Let's talk about maximum height so that we will not confuse you with a lot of writing like this in one place. Now, the maximum height we are talking about, say it is like this. This is still the U. This is U cos theta. This is theta. This is U sine theta. Okay? We want to derive this maximum height. Maximum height. Okay? Now, there is this kinematic equation, that is a motion equation that says V square is equals to U square plus 2AS. You know this is standard. Okay? Now, if you look at this motion equation, when we are talking about height, not horizontal movement, when you are driving car, running, whatever, is height. You shoot something, height. This is no longer A, become G. Instead of ordinary acceleration, we put acceleration due to gravity. Now we are talking about maximum height, maximum height. While the stone was here, what height did it cover? You flew, you get here before you came down here. We are measuring here. This is what Israel is using. When they are shooting down all those missiles against them, they calculate everything within a milliseconds through a computerized system. The same thing with Americans everywhere. So that's why you need to know this basic thing if you want to be a physicist. Now, because while an object is going up, the stone is going up, the force of gravity will be bringing it down. It's like an enemy. But when you are coming down, the force of gravity will assist you to come down. So this acceleration due to gravity is negative when you are going up. But when you are coming down, it's positive. So therefore, we are going to change this to negative. Okay? This is negative. Now, what is this in terms of height? Height is this. So we are going to replace this by U sine theta. But this is square, you put it square. Because we are talking about, okay? Now, while a stone is here, it is a little stationary before it comes down. That is, it was not moving. Velocity is considered when you are moving, when you are in motion. But if you ever stay in one place, even in milliseconds, in microseconds, your V is 0. So while you were here, you force yourself, oh, you came here, your V is now 0. So therefore, we're going to put 0 here. Then this is minus 2gx. Again, before I even come here, what is this small s? S is distance when you talk about horizontal. But when you talk about height, it's no longer s, it becomes h. So we are going to replace it with this h. We are going to call it h mass. H mass. So this is equals to h, small h mass. Okay? I indicated that earlier. Okay? Now, we are looking for this. So I can come here now and bring this to this side by saying 2g h mass is equals to u sine theta square. I divide both sides by 2g. This and this will cancel. It means therefore I'm going to have h mass as equals to u sine theta square over 2g. Let me rewrite this. U sine theta square over 2g. So this is the maximum height. Capital H or this. The height experienced by the object. You get the point now? You need to understand this thing I'm saying so that if you have any question or you are faced with any question in Projectile, you solve it with ease. Okay? Let's go back. This is done. The next one is time to reach maximum height. How long did it take you to get here? We need to calculate before the meter strike us. We need to reiterate very fast. We need to calculate how long did it take you to get to this location. That is what time take it to reach maximum height. Okay? To solve that, you agree with me that there is this another kinematic equation. That is a motion equation that says V is equals to U plus AT. Okay? And because we are still talking about height, V equals to U minus GT. Negative because it was going up. The same stone, just that now we are calculating time instead of height. So this is the time to get up. Okay? Now, this is 0 here. You see 0 here because you were static in microseconds. So we have to replace this with 0. What is this vertical is u sine theta minus g t up. This is a subscript. So therefore, you bring this to this side to have g t up as equals to u sine theta. So this is equals to u sine theta over g. This is the time taken to get up. It means if you are given a question calculating the time to get up, simply multiply the velocity, multiply by sine theta, the angle give you all over acceleration due to gravity. You get the answer, okay? This is done. That is this. The next thing is time of flight. What is time of flight? Time of flight is the time taken to reach the final point from here to here. How long did it take you, Mr. Stone, Mr. Bullet, Mr. Missile? How long did it take you when I shoot you, you came out to get to the striking point? How do we calculate that? So the total time of flight, we are going to call it capital T is equals to the time it took you to reach here. Remember, what we just calculated now is the time it took the stone to reach here, to reach the maximum height. It is the same time we take the stone to reach here. So to get this is whatever you got here, the time taken to reach here, multiply by 2. So, this time to reach up, you have to multiply it by 2. That is 2 multiplied by time to reach up. What is time to reach up? Is u sine theta over g. Time to reach up. That is the total time of flight. So when you are looking for the total time it takes an object to move from the starting point to the final point, you use this formula. What is the next one? We are through with this. Now range. Range is the distance between this point and this point. In meter, in kilometer, whatever. In miles, whatever. Now, how do we calculate that? That is range. I want to ask you, what is range now? Range is still distance. Just the way the money you pay to the family of your wife or your family receive as a woman is called dowry. The one you collect from bank is called loan. And the one you keep aside is called savings. That is the way we are calling distance, range. When it comes to projectile, the distance between the starting point to this point, that is this distance, is called what? Range. So it means it's still distance, but it's just that the name changed. I want to ask you, what is speed? Speed, you agree with me, is distance over time. But when we are considering the direction, this change to what? Velocity. Right? What is called to displacement? Time is still there. Now this and this are the same. It's just that this is speed that has direction. This is distance that has direction. The way you call loan, what you want to use to do, money, savings. If they overgave you money, we call it overdraft. It's same money, same cash with different names. The same thing with this. Why am I bringing this explanation into this? Because now we are going to use velocity equals to d, which is going to represent our distance now. Or you can also say x, because we are considering here to here horizontal distance. We can replace it with what? With range. Just the name change. So range now, if you cross multiply, you agree with me, is range equals to velocity multiplied by time. Which velocity? Which direction? This direction. That is horizontal velocity. Horizontal velocity is u cos theta. It means, therefore, we are going to replace it with u cos theta multiplied by t, range. What is this time? We capture you. What is the time? Think. You started from here. I reach here. What time is that? That is the total time of flight. Did you get that before? Yes. This total time of flight. We have to replace this t now by total time of flight. Let me just write it. In case you are doing screenshot. Time of flight. So therefore, it's u cos theta multiplied by, look at it again, 2u sine theta over g. 2u sine theta over g. Which is equal to, here now, 2, we bring 2 out. This u and this u, if you multiply there, is u square. That is sine. I take the sine first, I take the cosine first, you like. Then cos theta all over g. That is range. Now, I want to push this now to trigonometry more, to simplify it further. That is compound angles in trigonometry. What is this? When you have this plus this in trig, we say is what? Sine this, right? How do you express this? You say sine theta. I've done this in this channel. Okay, check it. It's there. Sine theta cos theta plus sine theta cos theta. That means there are 2, right? That is 2 sine theta cos theta. You get the point now? So now, do you see anything like that here? This is the 2 sine theta. It means I can replace this and this with this, because this is equals to this, that is equals to this. So therefore, I can come back here now as a range is equals to all this I mentioned. This is the only thing that escaped. U square sine 2 theta over g. So therefore, when you want to calculate range, u square sine 2 theta over g. Okay? Hope you understand everything I just explained. As I said earlier, if you don't understand this, play the video again, ask me a question, go to your textbook, do research. If you see that it's not going through, go and sleep, wake up, do it again.